In this video, I'd like to talk about how you can find the slope of a given line from a graph. And so, to answer the question, what is the slope of this line? To start this, we first need to remind ourselves what the definition of slope is. So the slope of the line is defined as how much the line rises divided by how much it runs. Or in other words, it's the change in the y values. This triangle here, this Greek letter delta, just means change in. So the change in the y values divided by the change in the x values. So essentially, how much does it go up? And then we're going to divide it by how much it goes over. So another way you might see this is the slope formula. So you find the difference in the y values, y2 minus y1 over x2 minus x1. So there's lots of different ways to define this. Sometimes I even just write it with arrows. How much it goes up and down divided by how much it goes left and right. So to answer this question, what is the slope of this line? The first thing I'm going to do is find two very distinct points. So what I mean by that is that this is a distinct point right here. It's very clear that this is at the point 0 for x and minus 1 for y. But like this point right here, this is not distinct. Yes, we do know the x value is 3, but we would effectively have to guess what the y value is. It might be 1.3, it might be 1.4, it might be 1.3872. It could be some really complicated decimal, so we don't really know the coordinate of that point, so we don't want to use that. And we want to find another very distinct point where we very clearly know the x and the y value. So this point right here would work. We might be able to find another one, or you could use this point right here. So whichever one of these you want to use is fine. You just need two of them. And then we're just going to count. How much do we go up from one point to the next? And how much do we go over from one point to the next? So let's count this. We go up from a y value of minus 4 right here to a y value of minus 1. So that's 1, 2, 3 up. So we go up 3. And then we're going to go to the right. We go from minus 4 to 0. So 1, 2, 3, 4 right there. So plus 4. And so our rise, how much we go up and down, in this case it was positive. We went up 3 units. And by the way, we usually use the letter m for slope. So I'm going to continue using that. So in this case, m, our rise would be up 3. And our run, how much we go left or right, we're going to the right 4 units. And to the right is positive. So you get 3 over 4. And we can simplify this, just drop the positive signs. So our slope here is 3/4. And you can see that this slope is consistent if we looked at our next two distinct points. Notice that you go from -1 to 2, so that's up 3. And then we go from 0 to positive 4, so that is over 4. So the slope is constant. You're always going up 3 over 4 on average between one point to the next. And this also should match up with some intuition because you should be able to recognize which slopes are positive, which are negative, and which ones are 0. Basically, you always want to think about yourself as marching to the right because we read in this country from left to right. So we're always marching in the positive direction. So the question is, as we're marching to the right, is our line going upward? That would be a positive slope. Is it staying flat? That would be a slope of 0. There is no steepness to this. Or is it going downward? That would be a negative slope. So you want to build an intuition. You want to be able to just look at this and say, oh, that's a positive slope, or oh, that's a negative slope. So as you're marching to the right, just ask, are you going up the mountain or up the hill? Or are you going down the mountain or down the hill? And if you're going down, it's negative, and if you're going up, it's positive. And if you're walking on flat ground, you can imagine, there is no slope. The slope is 0. So slope is just a measure of how steep the line is. And if it isn't steep at all, then we just say it has a slope of 0. So let's try another problem now. And we're going to follow the same strategy. you first always want to find two very distinct points. So let's look for those. We can use maybe this one. We can use this one. So this one actually has many distinct points that we can use. And now we just want to count. We'll use our slope definition. M for slope is rise over run. So in our case, it looks like, let me change colors, that we are going up from this point to this point. We're going up 1. And then we're going to go to the right 1. But notice this pattern continues for all of these. You go up 1, right 1, up 1, right 1, and it just keeps going forever. So our slope, our rise is positive 1, and our run is positive 1. So 1 divided by 1 is just 1. So this is the example of a slope of 1. And again, it should match up with our intuition, because as we march to the right, as we're going rightward, we are going up the mountain. So we can assume, just by looking at it, that it's a positive slope. And when we did the calculations, we did find a positive answer. So that at least gives us an idea that we're probably right about this. So let's move on to another problem. We've got 2 more that we'll do. Now looking at this one, as we march to the right, we are going down the mountain. And since we're going down the mountain, we should expect the slope to be negative here. But let's actually try and compute it. So we're going to find distinct points. This one looks pretty good right here. This one's not good, and this one's good right here. And then from one point to the next, so you go from a y value of 3 down to a y value of 0. So this time we're going down from one point to the next. So we go down 3, and we go to the right 1. And you can see this pattern continues. Here's another distinct point. You go down 3, right 1, and that would continue forever. So our slope here, our rise over our run, in this case, our rise is down 3. So let me rewrite that. So we go down 3 for our rise. If you're ever going down, it's negative. And we go to the right plus 1. And for our run, we're always just measuring how much we go to the right. So that's always going to be positive. So this bottom number, at least with this strategy, this bottom number should never be negative. The top determines if it's negative or not. So if you go up from one point to the next, like if you went up to here, that would be positive. But if you go down, then you're dealing with a negative slope. So in this case, our slope is minus 3 over 1, which we can just simplify to negative 3. So that is the slope of this line. And moving on to one final problem. Again, as we march to the right, we are going downward. So we should get a negative slope here. And this looks like a distinct point. Not that, not that, not that, or that. You got to go pretty far. So that looks like a distinct point right there. So M for slope. We know slope is defined as rise over run. So we just need to count how much we're going down in this case and how much we're going right. So it looks like we go 1, 2, 3, 4 down, so minus 4. And then we go over 1, 2, 3, 4, 5 to the right. And you can double check that because you were at 1 for the y value and you went down to minus 3. So that's down 4 units. And we were at negative 3 for x and we went up to 2 for this point right here. So minus 3 to 2 is 5 units over. So our slope here, M, is we go down 4 and to the right 5. So minus 4/5 for our slope, which matches up with our intuition because we expected this to be a negative slope because as we go march to the right, we are going down this mountain.